highways are evolving from simple roads to high-tech corridors that enhance safety, efficiency, and our sustainability. From solar-powered lanes to roads that charge electric vehicles as you drive, these smart highways are reshaping the future of transportation. Join me, we're going to explore 15 of the most incredible smart highways from around the world. Number 15. Rusgaard and Hageman's Infrastructure Smart Highway. The Smart Highway project, developed by Studio Rusgaard and Hageman's Infrastructure, is one of the most forward-thinking and innovative transportation concepts in the world. It's a Dutch initiative that began in 2012, and it aims to revolutionize how roads are designed. It encompasses a series of technologies that adapt to traffic conditions, harness renewable energy, and enhance your safety as you drive. The collaboration between Dang Rusgaard, a Dutch interactive artist, and Hagemans, a civil engineering firm, led to the creation of a pilot stretch of glowing roads in the Netherlands in 2014, specifically on the N329 highway in Oss, located about 62 miles southeast of Amsterdam. The glowing road paint used on this stretch absorbs sunlight during the day and then releases a green glow at night, providing illumination without the need for any traditional streetlights. In addition to these glowing road lines, the project includes a suite of other technologies such as dynamic paint that changes color based on road temperature, interactive lighting that brightens when vehicles approach, and wind-powered lights that use car drafts to generate energy. These features combine to create a road that's not only more visually appealing, but also environmentally friendly, which is nice. In addition, that interactive lighting system installed along the road is designed to respond to approaching vehicles. The lights automatically brighten as a car nears and dims once it passes. The interactive nature of this lighting also helps to create a more responsive and adaptable road environment. While Rusgaard's team envisioned these roads as living laboratories where they could experiment with new materials and technologies to create a more interactive experience. The use of self-powering infrastructure is really revolutionary, with the goals of roads generating their own energy to power streetlights and other systems, reducing our reliance on external power. Number 14. 3D Geowebs. So the 3D Geoweb system is a solution that enhances the construction of both paved and unpaved roadways, contributing to better stability, reduced maintenance, and a little bit of environmental benefit. This geocell-based system is widely used in road construction, where its design improves the integrity of roads by stabilizing the base layer. The unique 3D cellular structure strengthens soil confinement, increasing the strength of the subgrade and base material, and it even works efficiently with soft subgrades, where traditional methods may struggle. Unlike the traditional geogrid system, which require multiple layers to achieve a similar stabilization effect, a single layer of Geoweb provides superior performance. Now, while the exact timeline of its development isn't fully detailed, its adoption in various infrastructure projects began in the late 20th century, and it continues to be a key solution in road engineering. The Geoweb system is known for its ability to work across different environments. It reduces the need for large quantities of traditional base materials, often by 50%, making it a really sustainable choice. Its permeable structure helps to maintain stormwater runoff by allowing water to infiltrate the surface, reducing erosion and actually promoting vegetation growth. The system's been used for a variety of projects, including highways, embankments, retaining walls, and even airport runways. It's also used in slope stabilization, stormwater drainage channels, and erosion control, and in some instances, the system's even applied in recreational trails and green infrastructure projects, where it provides the flexibility for creating permeable pavements or vegetated retaining walls. Its ability to handle differential settlement better than other rigid systems makes it really useful in areas with shifting soils. Its use in green infrastructure projects has also made it a favorite among environmental engineers, aiming to create sustainable urban drainage systems. Number 13. Honking Roads. Honking Roads. It's an innovative road safety system designed to reduce accidents on some of the world's most treacherous highways. It was developed by HP Lubricants in collaboration with Leo Burnett in India. The system was first introduced on National Highway 1, which connects Jammu and Srinagar in India. This highway is notorious for its dangerous sharp curves and hairpin bends, making it one of the most perilous roads. The first installation of the Roads That Honk system took place on NH1. The highway, winding through the Himalayas, is subject to heavy monsoons, unpredictable weather, and often poor visibility. Given those conditions, road accidents are pretty frequent, and the need for a safety upgrade was critical. The system uses smart life poles strategically placed along sharp curves and hairpin bends, where accidents are most likely to occur. These poles are equipped with advanced radar and communication tech. When a vehicle approaches, the poles detect its speed using radar sensors. As the speed of an approaching vehicle increases, the frequency shift becomes more pronounced, allowing the system to accurately calculate the speed. Once the poles detect the vehicle, they communicate with each other to send warning sounds to the approaching vehicle. The warning is a horn, effectively alerting drivers of the dangerous curve ahead. The horns are activated only when the system detects that a vehicle is traveling at a high speed and may be at risk of an accident, giving them much-needed alert in a critical moment. This radar-based system ensures that the warnings are timely and reliable, functioning both during the day and at night. The entire system is powered by solar modules, making it an environmentally friendly solution that requires minimal maintenance. Number 12. The Electric Highway. The Electric Highway, also known as the E-Highway, is an ambitious project designed to electrify road freight transportation, significantly reducing fuel costs and pollution. First commissioned in August of 2017 by the German state of Hesse, the project represents one of the most innovative smart highways in the world. The system was created by Siemens, which had proposed the idea in 2012, aiming to combine renewable energy sources with the road transport industry. Now, the E-Highway system is based on hybrid diesel-electric trucks that can draw electricity directly from overhead power lines using pantographs, a mechanism typically seen in electric trains, to tap into the grid as they move along the highway. The system runs along a 6-mile stretch of Germany's A5, and it's the first operational installation of its kind on a public highway in Germany. The system is expected to show the feasibility of using overhead electric contact systems to power trucks along major highways, and it's a significant step towards reducing road freight's environmental impact. These trucks are equipped with pantographs that connect to the lines, allowing the vehicles to run on the electric power alone, and when the trucks exit the E-Highway, the pantograph disconnects and the vehicle switches back to its hybrid diesel engine. This setup allows trucks to operate at speeds of up to 56 miles an hour using electricity, significantly cutting down on fuel consumption. Siemens reports that if 30% of Germany's highway truck traffic were electrified through systems like this one, it could save up to 6 million tons of CO2 emissions annually. This would lead to significant savings in fuel costs. Around $22,000 could be saved by a 40-ton truck traveling 62,000 miles on the E-Highway. Additionally, the system offers cleaner air for urban areas by reducing local pollution, as trucks can operate on electric power instead of diesel. Number 11. Solar Road Studs. Solar road studs. They're a cutting-edge technology designed to enhance road safety and traffic management using solar power. These intelligent road studs are solar-powered lights embedded in the road surface, illuminating road markings and providing drivers with important visual cues. The first significant use of a solar road stud began in 2004 with a pilot project on the A50 motorway in the Netherlands. These road studs proved to be highly effective, especially for managing congestion and providing safety features during rush hour and bad weather. By 2008, the system had proven successful enough that it expanded to more highways in the Netherlands, including the A44 motorway, and it even started trials in the UK on the M8 motorway in Scotland. These studs integrated with dynamic lane markings, guiding drivers during times of congestion and increasing the capacity of existing roads by up to 40%. They help drivers quickly identify when the hard shoulder could be used as an extra lane, easing the flow of traffic. Each road stud contains solar cells and LED lights that power the system. During the day, the studs gather energy, storing it in batteries, and at night or in low visibility conditions, the LED lights are activated to enhance the visibility of the road, making it easier for drivers to follow the road. These studs are linked to traffic control systems, allowing them to respond in real time to road conditions. For instance, if an accident or congestion is detected, the studs can flash to warn drivers to indicate safe routes, helping to prevent accidents. These lights are 10 times brighter than traditional reflective road markers, extending a driver's view from around 300 feet to over 3,000 feet in poor conditions. Unlike traditional road lighting systems, which are expensive to install and maintain, these solar road studs use renewable energy to power their lights, making them cost-effective and environmentally friendly. Moreover, their autonomous functionality means they can be deployed without the need for additional infrastructure. Number 10. The Inroad Charger. The Inroad Charger concept, aiming to wirelessly charge electric vehicles while they're in motion, is a breakthrough that could dramatically change how electric transportation works. The idea is to power vehicles as they drive without the need for traditional charging stations. A major proponent of this technology is Electron, which has been working since 2013 to implement these systems, particularly in countries like Israel and Sweden. The technology works through dynamic wireless power transfer using electromagnetic induction to transfer energy from the road to the vehicle. As the vehicle travels over these embedded coils, it charges, extending its driving range without needing to stop at a charging station. Testing of this technology is already underway in multiple locations. For example, in the UK, Highways England is conducting trials with the aim of adapting it for use on motorways and A roads. The idea is, if the trials succeed, EVs could drive across long distances without the constant need for charging breaks. Several pilot projects have already demonstrated the feasibility of this technology, and as more cities and countries invest in electric vehicle infrastructure, the idea of an Inroad Charger is gaining traction. These tests are crucial for understanding the practical applications of the technology and refining its design to meet the needs of drivers and urban planners. But what sets this system apart from other smart road technologies is the ability to transfer power without contact. With similar ideas being explored globally, such as Stanford University's research on electric buses in Korea, this approach for the on-the-go charging is unique and has the potential to eliminate range anxiety for EV drivers. While it's still early days, there is no denying that this technology could revolutionize transportation. Number 9. Smart Pavements. Smart Pavements refers to a road technology that integrates sensors, fiber optics, and digital communication systems into the road surface itself. These sensors can detect traffic patterns, vehicle positions, road conditions, and even accidents in real time, relaying that data to emergency response teams or central hubs. The sensors not only track the position of vehicles but can also detect changes in pavement conditions or the occurrence of accidents, automatically alerting emergency responders. The initial pilot projects for the smart pavement took place in Colorado in 2018, where a segment of US 285 near Fairplay was fitted with those sensors. The system was designed to monitor traffic flow and accidents, transmitting any data to the Colorado DOT. In 2021, the Integrated Roadways expanded its efforts, working on a similar installation in Kansas. Their goal was to not only improve safety and traffic management, but also create a financially self-sustaining system by selling access to the data collected on these roads. This data can help in managing congestion, preventing accidents, and maintaining the road infrastructure. Additionally, the system's valuable information that can be used to predict and address maintenance issues before they even become severe. An interesting aspect of this project is the ambition to make the roads themselves profitable. By selling access to the collected data and services, Smart Pavement could fund its own maintenance and upgrades, creating a self-sustaining cycle of innovation and infrastructure management. While the first installations are in Colorado and Kansas, Integrated Roadways is looking to build a nationwide network of smart pavement roads, which could eventually lead to smarter, safer roads across the US and beyond. The technology, though, is still in its testing phases, but it's already received attention from other cities and governments, and the hope is that with further refinement, smart pavement could be used on a wider scale, offering a major step forward in the development of smart cities, and another way that corporations can get their hands on your data. Number 8. Pedestrian Safety. Pedestrian safety technology in urban environments has become a critical area of innovation. A standout example of this is the collaboration between the city of Tampere, Finland, and Tieto, a leading Nordic IT services company, to develop a pedestrian safety system using AI and the Internet of Things technology. This AI interprets the footage in real time, recognizing when a pedestrian is prepared to cross the street. When detected, an alert is sent to the automatic traffic signs, and eventually the system is expected to communicate directly with vehicles, warning drivers of pedestrians ahead. Under ideal conditions, the detection system achieved a 99% accuracy rate, and even in low light situations such as at nighttime, it did maintain a high detection accuracy of 75%. The system is built around an AI-powered cloud-based platform that processes the feed from intersection traffic cameras. The AI analyzes the movements of both the vehicles and pedestrians, predicting pedestrian intent and timing at crosswalks. Once a pedestrian's detected preparing to cross, the system triggers an alert to be sent to connected traffic systems like automatic street signs. This technology aligns with Finland's strict privacy laws, as the system doesn't track individuals but instead focuses on general traffic patterns and pedestrian movements. This ensures that the tech will remain compliant with the GDPR and similar data privacy regulations. But what makes this pedestrian safety system stand out from the other smart highway tech is its focus on integrating AI with urban infrastructure in a way that anticipates needs. The system's accuracy in both daytime and nighttime conditions, along with its ability to provide real-time data that can inform traffic management decisions, sets it apart as a forward-thinking solution for urban pedestrian safety. Moving on to number 7, the Astra Bridge. The Astra Bridge, developed by the Swiss Federal Roads Office, represents a groundbreaking solution to one of the most persistent issues in road management: the disruption caused by road repairs. The Astra Bridge was first tested on Switzerland A1 motorway in 2022, and a refined version was installed in April of 2023. Since then, it's become a vital tool in modern roadwork, offering a flexible, efficient, and safe alternative to traditional ways. Now, the concept of the Astra Bridge revolves around the modularity and mobility of the thing. Prior to construction, a section of the highway is closed for one weekend. These modular elements of the bridge are transported on trucks and assembled overnight. Now, once in place, the bridge spans the roadwork area, allowing vehicles to continue driving over the site while road workers work beneath. Drivers have to reduce their speed to about 37 miles an hour, but they avoid merging into one lane or waiting for signals to pass, making the commute smoother and faster. The bridge itself measures about 840 feet in length, 25 feet in width, and 15 feet in height, with a workspace underneath that stretches over 320 feet long. Once roadwork's completed in the area, the bridge is hydraulically raised by 4 inches and moved to the next section. Now, what sets it apart from other technologies used in smart highways is its direct physical intervention in the roadwork process. The modular design makes it adaptable, allowing it to be moved from one worksite to another, making it a tool for long-term infrastructure maintenance. In addition to its immediate benefits for roadwork, the Astra Bridge also represents a leap forward in the integration of tech into public infrastructure. This flexibility in design and operation provides a glimpse of future highway maintenance, where mobility and efficiency are paramount. Furthermore, by reducing the need for detours and stoppages, it also helps minimize fuel consumption and vehicle emissions. Number 6. The Green Spine. The Green Spine is a transformative urban renewal project that seeks to reshape a key section of Dubai's infrastructure into one of the world's most environmentally sustainable and accessible highways. Focused on a nearly 40-mile stretch of the Sheikh Mohammed bin Zayed Road, the Green Spine is being spearheaded by the architecture firm URB. This is all part of Dubai's long-term urban strategy, outlined in the Dubai 2040 Urban Master Plan, aimed at enhancing quality of life while preparing the city for a projected population growth to nearly 8 million people by the 2040s. The Green Spine will feature a solar-powered tram system. This tram network will be powered by a large solar panel array, which is projected to generate enough electricity to supply around 130,000 homes in Dubai. One cool feature of the Green Spine is the installation of over 1 million trees, which will help combat the urban heat island effect that's common in desert cities like Dubai. These trees are going to be planted alongside pedestrian walkways and bike paths, creating an inviting public space. Now, what sets the Green Spine apart from other urban renewal projects like the New York's High Line or London's Camden project is the scale of it and integration into an existing major highway. The Green Spine is going to tackle challenges of reducing car dependency, and as a result, it aims to reduce traffic congestion while simultaneously improving air quality, cooling the city, and creating a more vibrant and human-centered urban environment. While no specific completion timeline's been set, the project's inclusion in Dubai's 2040 Master Plan highlights the importance of it as a key part of the city's sustainable future. If successful, it could serve as a model for other cities grappling with urbanization and the need for smarter, greener, and downright awesome infrastructure. Number 5. G107 Ban. The G107 highway in Bao'an, Shenzhen stands as a vision of what urban infrastructure could become in the 21st century. Originally constructed to accommodate Shenzhen's rapid urbanization, the 12-lane, 18-mile corridor served as a vital transportation artery. The project, spearheaded by an international design competition in 2020, attracted submissions from 5 leading firms. Among the finalists was a visionary proposal by Avoid Obvious Architects and Tetra Architects and Planners titled The Organic Highway. Their approach aimed to reinvent the traditional highway as a sustainable and interconnected element of the urban ecosystem. The redesigned G107 challenges the outdated notion of highway as static, utilitarian corridors. Instead, it proposes a multi-dimensional layered system that serves not only as a transportation route, but also as a public space and a cultural hub. At the core of the redesign is a layered infrastructure that splits the existing 12 lanes into 2 elevated 4-lane enclosures. These enclosures are designed to reduce pollution by containing vehicle emissions while weaving vertically and horizontally through the big city. The highway would feature sections at grade, above grade, and below grade, creating an adaptable system that integrates with its surroundings. Transportation on the new G107 would prioritize efficiency through multimodal hubs located at intersections. These hubs would offer shared electric vehicles, buses, and high-speed rail options, enabling residents to travel across the city in about 15 minutes. Smart tech would be integrated throughout the highway to manage air quality, water systems, and traffic flow in real time. Now, these innovations align with their goal of achieving carbon neutrality by 2045, making the G107 a vital component of the city's environmental strategy. Despite obstacles, though, the project's innovative approach sets it apart. By treating the highway as part of a larger urban and ecological system, the G107 reflects forward-thinking philosophies that prioritize sustainability and community. If completed, the G107 Ban will serve as a global model for reimagining urban infrastructure. Its integration of green platforms, multimodal transit systems, and sustainable technology demonstrate how highways can evolve beyond their traditional roles. It's a vision for how cities can grow smarter, greener, and more connected. That transformation would not only improve the lives of the people there, but also redefine the role of infrastructure in shaping cities of tomorrow. Number 4. The Autoflow Road Project. The Autoflow Road Project. It stands as an example of Japan's innovation and determination at pressing logistical challenges. With the rapid rise of e-commerce and a projected labor shortfall in the transportation sector, this autonomous cargo highway offers a solution that could redefine global logistics. The project emerged from Japan's ongoing effort to tackle the so-called 2024 problem, a looming crisis in the transportation industry marked by labor shortages and increased demand for deliveries. By 2030, Japan is expected to experience a 34% shortfall in transportation capacity, threatening the efficiency of its supply chains. The Japanese government, spearheaded by the Ministry of Land, Infrastructure, Transport, and Tourism, initiated this project to mitigate those challenges. Now, unlike traditional roadways, the Autoflow Road is a dedicated network designed exclusively for autonomous electric cargo pods. These pods operate within glass-enclosed corridors, ensuring uninterrupted operation, protection from theft, and safety from weather. Each pod is capable of transporting standardized pallets measuring 3.5 feet by 6 feet and carrying up to 1 ton of cargo. These pods utilize quote-unquote buffering lanes to park temporarily, optimizing delivery schedules and avoid congestion at depots. These depots themselves are nearly fully automated, with robotic forklifts unloading cargo and preparing it for distribution. The initial phase of the project involves constructing a test track spanning about 300 miles between Tokyo and Osaka, Japan's busiest corridor. Estimated to cost $23 billion, this ambitious endeavor includes underground tunnels and advanced electric infrastructure to power the system. Test operations are set to begin in 2027, with a full deployment anticipated by 2034. Despite promises, though, the project is not without challenges. The high cost of construction, coupled with the possibility of advancements in autonomous vehicle technology in the meantime, raises questions about the system's long-term viability. Critics argue that self-driving trucks might actually render dedicated cargo highways unnecessary. However, if successful, the Autoflow Road could serve as a model for other nations grappling with similar logistical and environmental issues. Number 3. Recycled roads. In the realm of modern infrastructure, the introduction of jigsaw roads, notably the plastic road, signifies a transformative shift. This modular roadway system utilizes recycled plastic to create sustainable alternatives to traditional asphalt. The origins of the plastic road trace back to 2013, when 2 engineers at KWS proposed using recycled plastics to build roads. By 2015, their concept had attracted the attention of Wavin and Total, leading to the development of the first prototypes. In September of 2018, the project made its public debut with a 98-foot-long bike path in the Netherlands. This initial installation demonstrated the viability of plastic roads as a practical and environmentally friendly alternative to asphalt. The design enables seamless integration of utility pathways, allowing for pipes and cables to be installed or replaced without the need for extensive excavation. Furthermore, the hollow structure can store rainwater during storms, providing a built-in solution to urban flooding, a growing concern in many cities worldwide. Sensors embedded within the road can monitor traffic load, environmental conditions, and wear and tear, providing valuable data to improve future designs and optimize maintenance. The success of the bike path spurred further development, including a second pilot project. This installation tested the road's adaptability to weak soil conditions, and by 2021, Plastic Road had evolved into an independent company, ready for global commercialization. While the Plastic Road has primarily been used for bike paths and smaller applications, its potential for larger projects is significant. As cities face increasing environmental and logistic pressures, innovations like the Plastic Road could become essential. This technology not only repurposes plastic waste, but also redefines how infrastructure can integrate with urban systems. Number 2. Self-healing asphalt. Alright, let's stay on the road. Self-healing asphalt represents a solution to one of the most persistent challenges in modern infrastructure: road deterioration. First implemented on a stretch of the Dutch N218 highway in 2010, this innovation has demonstrated its potential to revolutionize road maintenance. At its core, self-healing asphalt incorporates small steel fibers into the traditional asphalt mix. These fibers make the material conductive, enabling it to respond to heat generated by an induction machine, a large magnetic device passed over the road. When activated, the machine heats the steel fibers and softens the surrounding asphalt, causing small cracks to close. This process prevents minor cracks from expanding into potholes and eliminates the need for frequent repair. This hybrid system extends the lifespan of roads, reducing maintenance costs and the environmental impact of road construction. The concept of this self-healing asphalt was first tested in 2010 on a 1,000-foot stretch of the N218 in Rotterdam. This highway section served as a proof of concept, showcasing the material's durability. Over the past decade, it's been deployed in at least 12 locations in the Netherlands, with some sections open to the public. Initial results show that while traditional asphalt typically lasts 7 to 10 years before requiring significant repairs, self-healing asphalt has the potential to double that lifespan. By 2021, this technology was being explored in other countries too, like China, where self-healing roads were built to test its viability in different environments. The N218, where self-healing asphalt debuted, holds a unique place in the history of this infrastructure innovation. Over the years, it's become a symbol of the Netherlands' commitment to pioneering sustainable technology. The self-healing section remains intact, providing clear evidence of its resilience. While other smart highway initiatives such as solar-powered roads and LED-illuminated lanes we've seen today focus on energy generation or safety features, self-healing asphalt directly addresses the structural integrity of the road itself. Number 1. The Solar Wind Bridge Concept. The Solar Wind Bridge stands as a concept that reimagines bridges as more than pathways for transportation. It merges renewable energy generation with infrastructure to create a dual-purpose system. Although the project remains unbuilt, this approach has captured attention and raised important questions about the future of sustainable infrastructure. The idea was conceived in 2010 by Italian designers Francesco Colarossi, Giovanna Saracino, and Luisa Saracino. It was developed as an entry for the Solar Park Works Solar Highway competition, which sought proposals to modernize a decommissioned highway. Their entry earned a second place, highlighting both its feasibility and the creative brilliance behind its design. The bridge's road surface would be replaced with solar panels, transforming the span into a 12-mile-long solar roadway. These panels, protected by a durable and transparent plastic coating, are designed to endure the demands of vehicle traffic while capturing sunlight. The designers estimate that this feature alone could generate 11 million kilowatt-hours of electricity annually. Beneath the bridge, the designers proposed installing wind turbines between its supporting pillars. Elevated bridges are naturally exposed to strong crosswinds, making this an ideal location for harvesting any wind energy. Now, what sets this solar wind bridge apart from similar concepts is the multifunctionality. Beyond energy generation, the design incorporates a green promenade along the top of the bridge, featuring solar-powered greenhouses. By merging ecological innovation with practical amenities, the concept transforms a functional structure into a community-centric space. However, the Solar Wind Bridge project is not without its challenges. The integrations of turbines and solar panels into an elevated structure demands advanced engineering. Additionally, the high upfront cost may deter potential investors, but even with those hurdles, the long-term benefits, both in terms of energy production and environmental impact, do make the concept worthy of consideration. While it does remain a concept, it serves as a powerful reminder of the untapped potential in existing infrastructure. It represents a forward-thinking solution to some of the most pressing challenges of the 21st century. Its design shows us the possibility of transforming everyday structures into multifunctional assets that benefit both people and the planet. Thanks for watching, everybody. I'll see you next time. Thank you to our channel members.